What's up, people? Okay, it's 11:11. Make a wish, dude. What's 11:11? The date. It's 9:45 in the Mernon, Central, South Louisiana. Tired because I went to work at UPS today and 3.5 hour shift, which is nothing you would think, but yeah, UPS will squeeze you. They'll squeeze you. Get every last drop out of you. Today actually wasn't that bad. I just went to bed late last night. I'm like, I barely got 7 hours of sleep. I need like 8 hours, honestly. That's just how I am. I know some people are like, oh, I got 6 hours of sleep, I'm fine. Oh well, not me. So anyway, yesterday we had a pretty good session. Good thing I ordered a new mic because also now my one of my earphones is not working, depending on where the volume's set, and it's kind of terrible actually. Anyway, so yesterday we finished reviewing all locks to ensure proper type for re-entrant versus non-re-entrant. We got that all figured out. We staged blah blah blah. Alright, so we're starting a new task today. And let's just remind ourselves. Oh, check extensions first. Remember that extension. And better comments extension for styling. It's better. So we have alert, which is exclamation point, star, asterisk is highlighted. Question mark is question. So I guess double regular comment out is strike through, and then to do is orange for to do. And yeah, my headphones are literally dying right now. Probably get my new one in the mail like any day now. They're just waiting on them to show up. I don't even know if my headphone's not working, you may not be able to even hear me on my, you may not be able to hear me speaking. My mic may also be going out. Isn't that cool looking? But I watched a little video this just a minute ago about Rider. I'd never really heard of Rider. It's like an alternative to VS Code. I use VS Code because that's just what I use, and it works pretty well. I switched from Atom, and I liked Atom, but I like VS Code better now that I'm used to it. It's just got, I think, way more like plugins, and I don't know. Maybe Atom did have all those extensions and stuff that I just didn't use, but either way, I use VS Code now. But Rider you have to pay for, and I don't think I would prefer it over VS Code from what I saw. Alright, so let's jump in. Oh, forgot to set my timer. Let's set to 65. 64, close enough. And so let's pick our new task. So we have, looks like we moved this one to the top. CS shared object mod C1 change attribute list logic necessity. I don't know what that means. So about a month ago, while reviewing this section, see lines 722, 739 in client pi, I wondered whether we need this logic at all. This section joins C1 change attribute list changes with C2 change attribute list changes if CS operation from client 2 into one larger list. Okay, I know what this is talking about. Do we actually ever modify shared objects from client side that would cause that logic to be used? If we don't need the change attribute list, source dict, and associated logic at all, right? Also means we would greatly reduce the amount of code and complexity of logic. Okay? If we do modify shared objects from client side, determine if we need the rule wherein we always use C1 change attribute list for those changes. If we don't need the rule, we can remove the logic at said lines altogether. Okay? But that implies we would have to add in logic in shared object setters and other places where we modify that would ensure the data point change gets appended to C2 change attribute list instead of currently where they all get filtered to C1. Yeah. IE ultimately modifies the data transfer function logic. Ultimately modifies the data transfer function logic so that the cow object in arg would be 2 instead of 1. Okay, so I kind of mapped this issue out. Let's jump to the file client, and it's 720-ish. Okay, let's see what we got going on here. Yeah, so this is the section because it referenced this change attribute list source dictionary. Okay, so what is this exactly? So we're in the client file, we're in the send section. At the beginning of the send section, we create the change attribute list source dictionary. It is a dictionary where the key is the index of the associated element from current client change attribute list. Val is the integer ID associated with the source of the element. So the key is the index of the associated element from current client change attribute list. Okay, so the first element that means the key is going to be 0. Second element, key is going to be 1, and then the val associated with each key is going to be the integer ID. So it's either going to be 1 or 2 depending on where the change originated from. Okay, yeah, so if it's from C1 change attribute list, it would be 1, otherwise it would be 2. And the purpose is to be used to depopulate the associated C1, C2 change attribute list afterward for removing all sent data from the proper list. Okay. But like, couldn't we just make a copy? You know, do we really have to do it that way? I mean, there's multiple ways to do it. I really don't care one way or the other. Let's just skim through this section real quick. So we have the definition, the index ref, a reference to the index of each associated element. Okay, this populates the change attribute list from the independent C1, C2. Okay, right, so this is combining C1 and C2 into the current client change attribute list into the 1, which is what's going to be sent, all the data that's going to be sent. Okay, so I'll see what I'm doing here. And yeah, so if current client ID is 1 or current client ID is 2, if the length of the C1 change attribute list is greater than 0, then C1 change attribute list copy equals copy, current client change attribute list equals C1 change attribute list copy. Okay. And then for toop in the copy, we add each element from that, all the data that's going to be sent. So we create a copy of the change. So if the length of the C1 is greater than 0, we create a copy of it. Okay, so we take a snapshot, and then we do current client change attribute list equals C1 change attribute list copy. Okay, so now the current client equals the snapshotted copy. Then we iterate through the snapshotted copy, and we assign to the change attribute list source dict each element relative to its index, with the value being 1 since it's originated from the C1. Then we increment the index ref, and that makes sense. There's nothing wrong with that. Alright, now then we check if current client ID is equal to 2, and if the length of it's greater than 0, then we get the C2 change attribute list copy. Okay, so we make a snapshot of that one, and then if the length of the change attribute list is greater than 0, which means if we had run this section above, then we would iterate through that copy and append each tup element to the current client change attribute list. So now it consists of 1 and 2's entries. Else, then we just assign the attribute to this copy since it was empty. Then we iterate through the C2 change attribute list copy, and we add each entry to the dictionary with the value equaling 2. Okay, fair enough. And then we increment the index ref, but wouldn't the index ref be wrong? Because the index ref starts at 0, but then we're iterating through this copy, and the index ref will get incremented. Let's say there's 5 elements, so it gets up to 5, and then we go to the C2 change attribute list and make its copy, and then we begin iterating through that copy, but we're accessing the we're accessing or trying to add on to the dictionary at the index ref of starting at 5, but that's not gonna work because that's not a real index reference. That is just like a counter. If you were to later use index 5 to access index 0, since we would start at index 0 in the C2, that would not be correct. So let's see what we do with this. We have some clever in that. So then we check the length of the current client change attribute list. We get the element index, which is the index reference. Remove tup equals false. Will be switched to true if any elements are removed during below dir check filtering. Will be switched to true if any elements are removed below dir. Okay. For tup in the current client change attribute list copy, so we create a snapshot of that. Because we're going to remove from the original. Okay, so then we say dir check, and we're checking out this data dir string receive bool other client bool strings to do. We can start game, and anyway. Current client do not send editables, and removed tube equals true. And now a current client change attribute list remove tube. So we remove it from the actual change attribute list. If the change attribute list source dict at element index is equal to 1, sorry, I gotta use the restroom real quick. I'll be right back. Okay, I'm back. And alright, so we iterate through this copy, we run dir check, okay, and then we say if the change attribute list source dictionary at element index is equal to 1. Okay, then we remove okay, so actually the element index is irrelevant. It's really just a counter because we don't use the index to remove it. We use the remove method, not the pop method. So we remove the actual tube. And I can't remember if remove is faster than pop, and if it matters. It really doesn't matter, like it's splitting hairs, I would think. So then we say else, we would remove from the C2, and then we would delete from the change attribute list source dict the element index. And then we would say current client do not send editable set to false. Okay. And so we could actually change this first. So we delete from the change attribute list source dict at element index, which is fine, and then we increment the element index. Okay, so really this is just this is really just a counter. It's not the index, so that is misleading. So we should, this is not a reference. This is a reference to, we'll just call this, instead of index ref, we'll call this the dict counter, and we'll call this a counter for each associated dict element. Counter for each associated dict, and we'll just call it dict key because this technically refers to the key. A counter for each associated dict key. So we'll just call it a dict key counter. That's even better. And now we can use this instead of index ref because that's not good. And now go down here, we do the same thing. And do we need this code duplicated, or can we have it just be run once? Well, no, because we need to make a copy at this point in time, and then we have to assign that at this point in time. Technically, though, these three lines don't need to be run twice, but this does and this does. But this could be. Let's see. Group and C1 change attribute list copy. Change attribute list source dict at dict key counter is equal to 1. Well, actually, yeah, these are. We could assign these. It would end up being the same amount of lines. I was gonna say, like, we could save lines, but really we would have to add lines to save lines, and it would basically end up being the same, give or take a line or two. So we're not gonna change that. All right, so then we have the. If length of C2 change attribute list, blah blah blah. All right. Continuing on, we have if length of current client change attribute list is greater than 0, the element index equals 0. Okay, so we'll change this also to be called the dict key counter, which is well, let me see. Alright, so we have the element index, change attribute list source dict at element index. Yeah, so this is we could call this the element counter or the dict key. It doesn't matter. Yeah, we'll just use the same name, I guess, because it's like the same thing. Dict key counter associated with each key of dict. We'll just call this the dict key counter. Like, we don't even need a say incremented by 1 every iteration. Yeah, it's pretty self-explanatory. We don't need to really go through all that trouble. So now we're going to change this. We're going to change this and this one as well, and then this one as well. So this is just dict key counter now. That's a better description. It is not an index reference. It never was. So yeah, there's nothing wrong with this code. This code is fine. But is it necessary? So let's finish this last little section. If the length of the change attribute list is greater than 0, this is after filtering. If remove tube is equal to true, which means we removed any of them, then we have a new change attribute list source dict in a new index ref. Why do we do this again? So if we removed some of them, so we checked the length up here. We checked the length of the change attribute list. If it's greater than 0, then we create a copy. We iterate through it, filtering it with dir check. And if we find that it needs to be removed, then it gets removed from the change attribute list, and it also gets removed from the actual, and it also gets removed from the source dictionary. Okay, and then if the length of the current client change attribute list is greater than 0, okay, so then we check the length of that again. That's fine. And then it says if we removed anything, then we have a new change attribute list source dictionary. And then we say, why is this? Reassigns the leftover elements from the change attribute list source dict to have a new set of element index references, since the old references have been disrupted by the removals, but they weren't actually index references. We didn't need them for such in that way. Maybe initially I planned on that, but that's not what ended up happening. Remove at least one tuple element in the above dir check filtering section. Okay. Then we say for key in the source dict, the new one at the new index ref. So this is dumb. We don't need to do this. This is stupid. That's not smart. Like, no. We already have, like, the change attribute source dict gets it gets adjusted to reflect what should be sent based on the dir check filtering. They get deleted from it. And since the dict key counter, really it doesn't matter what the number is because it's not an index reference, we could then just use the source dict like as it is. There's nothing that needs to be changed. Don't forget about our little cat down here. What does it want? What does it want? It's swiping. What is this? Wave? It's just waving to me? Okay. Um, so this, I'm pretty sure we could remove that. Then we check the current client ID. We get the send data storage dig, the send ID. The current client send ID increment. Pre-serialize the data. Dumps, and then message head, and then we send the data. So like, what do we even need this for? What does this even get used for? Okay, so after we send it, we then iterate through a copy of the change attribute list, and we would remove the sent data from the C1 or the C2 change attribute list. Okay. That's, we would remove. Okay, so then we're saying if the change attribute list source dict add element index is equal to 1, we would remove from the C1, and then else we would remove from the C2. Then we have the current client change attribute list remove the tuple, and then we increment the element index. So at this point, there's a few things that I'm noticing. So we're iterating through the change attribute list copy, but I don't think we need to make a copy of this. B, iterate through the current client, copy the copy to remove all entries from the source change attribute list, the actual list that were just sent over the network to avoid sending them again. This is used instead of clear to avoid accidentally removing data that got added in between the send and this removal. Okay. Yeah, but we don't need to do that because this is already a snapshot. Like, this is not dynamic. This is not being added to. See, let's go up to the top and we'll verify that. So yeah, stupid ass scroll wheel on this mouse. I probably should have bought a new mouse. I didn't buy a new mouse. I probably need to buy a new mouse, bro. It's time. Because that scroll wheel, it's broken. It drives me crazy. Anyway, so we have the change attribute list assignment right here, the highlighted. And it is a snapshot of the actual C1, and then it gets added to, but it only gets added to right there. It's not going to get added to, and this is on the client side anyway, so there's not like multi-threaded addition anyway. So like, even if we were like, does that mean Yeah, there's not multi-thread on the client side, and this is client side. So doesn't this actually mean we don't even need the current client change attribute list, like as a copy? Couldn't we just check the length of the C1 and create a copy right here, and then iterate through the copy? We can assign to the source dict, that's fine. And then okay, because we use that as a compilation, and that's fine. That's okay that we do that. So then we say if the length of the 2 is greater than 0, we create a copy. Yeah, but we don't need to do that here. Like, we don't need to make a copy of the C1 and the C2, because on the client side there's only one thread. We do that on the server side because there's multiple threads, and there's the concern that the main thread is going to be adding data to the change attribute list while this execution is happening on the other client threads, and that would result in bad data. But yeah, we actually don't need to worry about that on the client side. So this, okay, here's what I'm going to do. I am going to copy this whole little section, and this is just going to be reworked. But really, the bigger question, and this one of my biggest problems, is forgetting to zoom out. So the main thing that we're looking for here is the necessity of this. So I understand that this is coded, but is it necessary? And what I'm asking is, if we're running this from client 2, do we need to even check the C1 change attribute list? Meaning, is any data change concerning a shared object, which would be like the deck, it's like the master deck is basically it for the most part. And I'm not sure about that, like that. So how do we know, like, what are all the shared objects? Well, the shared objects are for sure, they're all the things that are sent via change attribute list. Well, not all of them, but it's really hard to figure out a way to define exactly what they are. But I know that the deck would fall into that category, and I think that's pretty much it, just the deck. So is there a good reason for us to do it that way? I don't want to assume. Let's see, let me go back over here. We have the data transfer function logic, so that cal object would be 2 instead of 1. So let's look at this real quick. I want to see if I can find which of these are so CS equal to SS, cal object equals C1. Okay, so cal object int, let's see. Okay, so anything that has to do with the cards are shared because these are set to 1. So that would be like card group data. But I'm quite certain that card group data only gets sent to deck adders are not shared. Verified that. Okay, so I'll put here player objects are not shared. Please look to determine if player objects are shared. Verify that none of the P1 class adders are shared, meaning they don't need locks. Deck adders are not shared. Verify that none of the deck class adders are shared, meaning they don't need locks. Okay. So ultimately, I think what this means is, if this is correct, which I think it actually is correct. We always assumed that the client side would modify the deck and stuff at some point, but it actually doesn't. Now, the reason that okay, so if from the client side we don't ever modify the deck, the discard pile match card ref list, or the original deck, or the prior face-up discard from the client side, then that means we don't need to check C1 change attribute list on client 2 client side. You see what I'm saying? If none of the client side changes from client 2 would involve any of the attributes which are always appended to the C1, then we do not need to check that. It would always just go off of your client ID. So if you're client side 1, you only check the C1 change attribute list. If you're client side 2, you only check the C2. That means we don't need that dictionary. We don't need to combine them. We don't need to do all that extra stuff. We could chop out a lot of that code and make it a lot more simple and more performant, etc., safer, all that stuff, more readable, more secure, blah, 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 blah. So we have to do what we were doing. We're on the right track. We're going to go through and see what all cal object int equaling 1. This is going to be all the things that are quote unquote like shared on the server side, where whenever they get changed, we don't really know who should send them, like, because it's not relative to a client 1 or client 2. It's just they both use the object. So it's like, well then, but one of them's got to send the data over to the client side. Who's going to send it? And we just have said, okay, well, client 1 is going to be the one to handle the shared object. So we just always put the cal object int equal to 1. Which is good, and that's fine. There's nothing wrong with that. But if we don't send that from the server side, which I don't think we send any oh, this on CSS doesn't even do. Yeah, if we don't run this on the client side, or rather if we don't transfer the data from the client side, which means if we don't modify it, like we modify it but not in a way that results in a data exchange via card group data. So let me write down the ones that need to be checked. So we need to check to see if card group data is ever exchanged from the client side. Let me just zoom out real quick, because it's kind of a mess of thoughts. It's spaghetti thoughts. It's a lot of things coming together. So yeah, I think I'm on the right track here. If we don't send anything that is always sent through C1, then we only need to check relative to our client ID on the client side. Yeah, point blank period, the end, very simple. Data transfer function. Okay, so this is going to be self ID. So this one is going to be, alright, so but this one is 1. So this is going to be the deck or the discard pile. So the dot deck and the dot discard pile. And I'm pretty sure we checked all this. And this is why it's good to keep some stuff in the notes file, because if I would have like written that down as a note, I wouldn't have to check this again, but now I'm gonna have to check it again. So here's the same thing with deck and discard pile. Same thing, deck, discard pile. What's this? Prior face up discard. Okay, so that one also needs to be checked. Okay, so here we go. This is card group data. Yes, that's the same thing. We're gonna check that. Okay, so that's it. That's actually not a lot of stuff to check, which is cool. So we can get rid of this. Now let's do Control Shift F and we'll do let me see. Instead of actually checking this legitimately, which object did you pass due to card group data's so sections direct modification of the card text by address to immediately display the update. I was gonna ask about this. Why do we pass the current game? And it's saying that current game is the current game object which must be passed due to the card group data section's direct modification of the card's XY adders to immediately display the updated card locations via an associated draw window main call. So that must happen inside of dircheck. Okay, yeah, so yeah, we call draw window main immediately. So we do need it in certain instances. So we actually only need to pass the cur game in the case. And couldn't we just pass the ID? Yeah, we totally could. We totally could pass just the ID. I'll put this as a thing to do. Yeah, because that's definitely something we could fix. Oh yeah, there's a new way we do this, which is alert, right? Yeah. Section, put the date here, 11/11/24, and let's see, cur game isn't actually necessary here. We can use the game ID instead, which is much more efficient and simple. Definitely change this. Yeah, that is true. Yep. Okay, so anyway, we'll get to that eventually. Let's keep going through without getting distracted. Alright, so we're here, and I was trying to see if I could find if card group data. Okay, here we go. It only run on CS, and this is the cool thing. See, I can look using this extension. Continue removal of Pygame code from server side and related tasks, and this was one of the things. See, we added. This is why this fucking awesome extension, bro. What is it? Get something. It's a it extends the functionality of Git, and this is so cool because this lets me know. See, it shows me my change. I added in on client side, which means card group data is only transferred on client side. I'm going to add that to the notes though. So we'll here and we'll put card group data only run. Wait a second. Did I just read that? Am I an idiot? Only run on client side. Because this is for receiving, which means server side never receives card group data. Yeah, because if it's received only on the client side, then that means the server side never receives. True. So let's, yeah, we were right. I just wanted to verify that. Card group data only sent from server side to client side, never from CS to SS. Therefore, don't need well, we'll just leave it at that. Just, you know, bam. Okay, so now we know card group data is, we'll put equals no CS send, and now we'll check deck. So we'll do .deck, but that's not actually gonna do it. And I have to piss again, dude. Damn. It's that coffee. It's that coffee, dog. I don't know what what does Bernie Sanders have to do with break? I don't know. Anyway, silly gifs. Silly gifs. Okay. Oh, where were we at here? We got 8 minutes left, dudes. Okay, so we're trying to figure out if deck is sent. That would mean that the deck would be appended to, popped from, or cleared on the client side, right? Yeah. does it do this? Why does it do that, bro? Wait, did it fix it? Did I just figure out how to fix it? Oh no. See how it scrolls to the right? Sometimes. I don't want it to do that. Okay, no, yeah, that doesn't work. I have to literally use my mouse and go over here to do that. So the draw animation is run server side. And then that gets sent to the client side, but never the other way. And all this is going to be server side to client side. So again, none of this is going to contribute to client side to server side, which is what we're looking for. Now here in setup, we don't transfer that data. Yeah, we still don't transfer data at this point. Okay, so we're safe. We don't transfer .deck data to the server side from the client side. Yeah. Okay, so then we'll just put over here, we'll put equals no CS send, and then we'll go over to notes and we'll add this as well. This is going to be .deck data only sent from server side to client side, never from CSSS. We never modify the deck from CS in such a way that it is transferred. True. Alright. And then we need to look for .discard file. And let's see if we can see if that happens. So this is dir check, and this is for prior face up discard actually. Oh, if it's not equal to prior face up, I'm tripping. Yeah, but it wouldn't result in a subsequent data transfer. So this one we don't have to worry about. We have discard file here. Alright, keep going. Discard file. And this is all going to be client side to server side. That means, or the other way around, server side to client side, so we don't have to worry about that. And then setup, we're not going to have to worry about setup. And that's it. Okay, so there we go. There's another one we figured out. And this one's going to also be equal no CS send. And then the last one is going to be prior face up discard. Alright. So yeah, we don't even have to look because that's all going to be server side to client side. Oh, but we didn't. Let's add this to notes. So discard pile and prior face up discard is no CS send. Okay. Let's copy that. Paste. Oops. There we go. And this is gonna be dot shit. Can't. Fuck. It was dot discard pile and then prior face up discard. Was that it? Yeah, whatever. I'm pretty sure that was it. Discard pile, and then we have prior face up discard. Yeah. Okay. Bam. There we go. So long story short, that means we don't need that section at all, right? That means we don't need this wherever it is. I heard you, I heard you, I heard you. Alright, so I'm gonna take a little quick break. I'll be back in a minute, okay? And we're gonna get rid of this section here. And let's separate these two. So these two go over here. We have things to do, which is gonna be I guess we'll have it be green. Could not update tab color. Why? Why? Why, my friend? Why don't it work? I don't know why it's not working. Let me close it and open it again. Maybe that's why. Yeah, there it goes. Okay, cool. So this one's blue, red. It remembers. See, and it remembered the color that I was using. And then we'll just have this side be like green. It will just kind of help me too. Alright, so the section that we were dealing with was, let's look at this cal object int. If you can say equals 1. Equals 1. deck, discard pile. Yeah, we already did this. I'm not doing it again. I just wanted to be sure. Okay. So this section is what, 720 in client? Yeah. So we're gonna end up removing this. So we'll put this in things to do. We'll say determined update 11/11/24 determined after review this whole section doesn't need to exist. CS always only transfers data in terms of its associated .id, i.e. C1 always uses C1 cal, etc. Therefore, remove/refactor this section accordingly. Alright, yeah, so we're gonna do that after break. So I'll take a little break and I'll come back and we'll finish this. And man, I'm tired today. Holy shit, I drank a lot of coffee and I'm just like, it is not doing the trick, bro. You know, it's not doing the thing that it does, you know. Coffee, sometimes it works really well, sometimes it just kind of like is ineffective. I mean, I got like I got like 5 minutes less than 7 hours sleep. Honestly, I didn't think I would be this tired, so I don't know why, but I am. Like, my brain is just not working all the way, you know? It's not a good feeling when you're that, like, when you're just tired, your brain doesn't want to work. I'm sure you know. I'm sure you've experienced it. I see my vitamin pill stuff doesn't taste so bad. I mean, the mushroom one doesn't taste so bad, but the freaking vitamin one, it's kind of gross. Caffeine pill literally tastes like nothing. It's a little bitter. It's kind of like ibuprofen. So I'm like, should I just go to the gym and work out and come back, or should I do a little bit more? We'll do just a little bit more and then I'll take a break and go to the gym. So anyhow, yeah, I'm gonna take a small break. I'll be back in a couple minutes, and I'm gonna go for a little walk and try to get my blood flowing. Hopefully that'll wake me up a little more. I'll be back a second. Okay, I am back. I know that was like a super long break, but yeah, it's like 20-minute break. I used the bathroom and stuff. Took a little walk, made a little snack. All right, so I think I'm just gonna do this last little bit right here, and then I'm gonna go to the gym. Namely, we're going to basically, like, we don't need the source dictionary anymore. We don't need to check, like, we don't need to check this stuff. All we need to do, well, we do need to run dir check on it. So copy this, and then so alright, let me just, I'm gonna copy this whole section, and we're gonna pretty much get rid of almost all of it. We're gonna refactor. So yeah, this is basically the entire send section actually. Okay, now I know it's gonna have the indentation messed up. This one we're gonna go down here and we're gonna comment out all this like so, and I'll put a note here. Being replaced by section. Alright, now let's go up here and fix this. Div it out first. We'll say alright, so let's fix it here. So now we don't need this, we don't need that, don't need to check that at all. But we do need to check if current client ID is equal to 1. Then we'll say the length of the C1 is greater than 0. Else, which would be elif current client ID is equal to 2. So we do need to make a copy. So we would make the C1 change attribute list copy. Well, no, actually we don't, remember, because this is client side. So like we don't really need to make a snapshot because it's not being constantly adjusted. So that's, yeah, that's not true. We don't need to make a copy. We don't need to do any of this. We don't need to do any of that shit. Okay, well then we would iterate through it. So to remove the current line change attribute list. And then say current client change attribute list equals C1 change attribute list. And then here we'll do the same thing except C2. Now we run our dir check. We use the copy. Okay, and that's I think good. I think that's what we would want to happen. So we iterate through the change attribute list copy so that we can remove from the remove the two. And this means we're also removing it from the C1, right? Yeah, if we have a list and we make it equal to that list, and then we make another variable name equal to that list, when we modify the new namespace that refers to the original list, it modifies both lists. Well, it's the same list, but it modifies both namespaces. So then we have current client change attribute list remove to current client changed attribute list remove to, yeah, so that's gonna remove it from both, from the original and the change attribute list. Then we don't need this. We don't need that. And we don't need that. We don't need that. And then we check after iteration to see if we need, if it's still populated. Okay. So this needs to be unindented. So we check the length of it. The current client change attribute list greater than 0. Okay. Yeah, if the current client change attribute list is greater than 0, after we have, see, this is messed up here. We say, yeah, so we check the client ID, then we check the length of the associated change attribute list, then we assign it to current client change attribute list so that we can refer to it as such. Then we iterate through the change attribute list copy, running dir check to see if anything needs to be removed, and for each one we check if the do not send data bool is set to true. Inside the dir check we set it back to false if so, and we remove the tuple from the actual change attribute list, which would remove it from the reference and the actual. because they refer to the same object, which is what we want. And then we check the length of the change attribute list again after filtering it to make sure it's still populated. This comment is dead now. Yeah, so all this is right so far. And then gotta remove this discount double check though, because I didn't actually double check this. Alright, so we check the length of it again. Yeah. And we don't need this. Don't need this, that. Don't need any of that. Get rid of that div. Checks current send ID. Okay. And we could, well, we can leave it like this. Send data storage digged. Okay. Now we have the pre-serialized data, the data and message head. This can be moved. Data, pre-serialized and message head. We'll move this to happen after, and it messed up the indent. It always does. And this is going to instead be current client ID. And we're going to send the change attribute list, which is perfectly fine. Pre-serialized data, message head data. Then we log the current client change attribute list send, which should be correct. Then we have the network socket where we send all. Message head plus data. Okay, yeah, so this is right so far. So data storage send ID equals pre-serialized data element index. We don't need this anymore. Yeah, so yeah, this element index can go away. So we are going to iterate through the copy. Iterate through the current copy. Copy of the copy. Well, it's not actually a copy, it's a copy of the reference. To remove all entries from the source change attribute list. Say the original changed attribute list that were just sent over the network to avoid sending them again. This is used instead of clear to avoid accidentally data. They just got added. Yeah, we actually can use clear. Yeah, because that means we would have sent everything. So after we sent, so we populate the change attribute list attribute via assigning it as to the C1 or C2 attribute list. Then we iterate through a copy of that reference, filter out things that don't need to be sent, remove them from the attribute, which also removes it from the original since they're the same object. Then we check to see if it's still populated. If it is, we go ahead and get the data ready and then send it. And then we go ahead and what do we do next? Okay, so then we assign to the sent data storage dict, so we store it, and then we iterate through the copy. But okay, so at this point we have sent everything in the change attribute list. So all we need to do is, at this point, is clear the list, because we're on a single thread. We just sent everything that was in the list. So then, instead of iterating through it, we could just say dot clear, and that in and of itself, we would, yeah, just from that one line, we would clear everything that was sent. Clears everything that was sent over the network from the changed attribute list, and C1, C2 changed attribute list, since they refer to the same object. Clears everything that was sent over the network. This can be done on CS since single threaded. No data loss. Yeah. Yep. So yeah, we populate it. We don't populate it. We create the current client change attribute list, which becomes the C1 or C2. They refer to the same object. We filter that object, we send that object, and then we just go ahead and remove everything from it by clearing it, which this will remove it from the attribute and from the original, since they both refer to the same object, because all that just got sent over the network. And bam, look how simple that was. That was extraordinarily simple. That was great. Fantastic. Now let me just go ahead and test real quick to make sure that we didn't mess anything up. So look at this. This was like what? This was from 733 to all the way to 818. So that's like 85 lines, right? Now it goes from 694 to 729, which is what, 35 lines? So is it like 85 versus 35 or something like that? I just said. Yeah, 85 versus 35. So this was like a 70% code reduction or something. This is like more than 50%. It's like 60-70% code reduction. So much easier to read, so much shorter, so much more simple. Less prone to bugs, etc., etc. So really happy with that. Now let's go ahead and test it. So we're gonna do Canasta main. What's this? Paste that. Paste that. Go over here. Run the server. Just pi. And then we'll run the clients. And we'll do it again. And we should, it should be a little faster now. And in Python, the performance changes you make, when you fix code like this, because Python is a slower language, I mean, it's still very fast relative to just like human perception, but like It's compared to other languages, it's really slow. It's gotten faster, but anyway, you can notice the performance changes when you improve, you know, certain sections of code. It seemed like, I don't know, maybe my perception, but it seemed like it faster. I could be wrong. Some of those operations take a good bit of time, you know, from the stuff that we like cut out. I probably was just imagining that though. I like to think that I can actually notice the performance changes when I improve the code in such a way that would improve the performance. It's like hopeful hallucination, you know. It's like a subconscious encouragement. It makes you think like, hey, yeah, it's running faster. Look, I can tell. I can just see it. That work I just did was definitely worth it. Because I felt like it's faster. Because now I feel like it's faster. Yeah. So it actually does seem like faster though. I'm not just saying that. It really does seem smoother. Could be. So it looks like everything's working so far, but let's just make one full play to verify it, and then I'm probably gonna go to the gym. And today's heavy bag day, and God, I always go so hard on the heavy bag, honestly. I got a little bit out of shape being out of work because of hurting my back, and I could just like see it in my body, like I'm not cut, you know. I lost the cut. I don't think I really lost muscle. I think I actually gained muscle because I wasn't like burning it off at work. Like at UPS, you will burn a lot of calories, and I think I probably like stay cut from working there, but it kind of also, you can cut muscle too, and I don't really want to cut anymore. Like I want to be in shape, you know. I want to have like a six-pack and stuff like that, but I really don't want to like cut weight, because cutting weight means like I'm gonna lose some muscle, and I don't want to lose like any muscle, because I really need my muscle. With having like problems with my back, I need every bit of muscle that I can you know, that I can muster, because it's gonna help me, you know, with lifting, and it's gonna compensate for those bad joints or whatever it is in my back that messes me up and causes me a lot of pain. I can go with a little bit of belly on me. I would rather have just a little bit of belly and know that I kept all my muscle than be like super cut, but you know, I'm probably like losing a little bit of muscle each time I go to work at UPS. And eventually, like, the muscle buildup will reach the level where like my calorie intake, you know what I mean? Like, I should get cut again, as long as I don't like increase my calorie intake, you know? If that makes sense. Anyway, so it looks like it's working good, and I'm like confident that this is a successful refactor, because I'm just like, I'm good like that. And yeah, I actually feel like we could just delete this. We don't need to save it. But just to be safe, what we'll do is what we usually do in this situation, which is we'll copy it. And I almost forgot that I do this, but we're gonna be smart, just in case. We're gonna go to text and old feature storage, and we're gonna paste in the old feature, and the indentation is gonna be fucked up because VS Code does that. I don't know if they all do that, but you'll hear me say that like 1,000 times throughout a coding session, on any given session, just because it's true. English love section. Put was replaced by new section, leaving until I'm 100% sure replacement is valid. Yeah. We'll just put file, client pie, lines, number. This is basically 689 to 728. And then put was replaced by new section. Yep, so that's good. Alright, so we can close this out now. And we'll go ahead and quit for now. I'm gonna exit out of this. We'll go to things to do. We took care of this task, and we'll put ... Go to devlog. We'll say finished, begin, and finished refactor of client pie send section. And finished entire factor of entire client pie send section. Began and finish refactor of entire client pie send section. Massive improvement. Massive improvement tested via game test, and everything is working as it was. Okay, and that was from 9:45 to 11:45. There's no way. Well, I did take like almost a 20-minute break. It was like probably closer to 15. It wasn't quite 20 minutes, but I'll still say we only did an hour and a quarter because I don't really count that. So we'll just actually say 11:30. I like to be, I don't want to say I worked longer than I did, but did we really? Like, that's 2 hours? That was fast. 2 hours, man. Hour and 45, really. So yeah, 1.75 here. Yep, that's adding up. So let's go to things to do, and it looks like our next thing. Look at this list, bro. It's getting so short. Holy shit! Wow, I'm so happy. Sort of. I know we still have a couple like difficult tasks. The save section and the accounting for lost data. There's another little section we have to do. This is client-side to server-side data not sent to other client. Realize that data changes made client-side that are sent to the server are never actually transmitted to the other client. And the primary concern should be whether or not these changes are needed by the other client. Yes, because if they're not needed, then we don't need to implement that. Not needed, no need to implement. Need to review the necessity of this. After brainstorming, determined it would be quicker to figure out if we actually need to transfer this data than it would be to implement a We'll go through each file's transferred adders minus game pie. Wait. We will go through each file's transferred adders minus game pie's non-transferred adders minus progression server side only to determine which adders would need to be transferred. Finalizing a list of all needed adders from other clients client side. Yeah, I don't really know what I mean, but when I say go through each file's transferred adders minus game pie and non-transferred adders, like that doesn't make sense to me. Hold up. Yeah, so that doesn't make sense to me because I mean, why would we look at the non-transferred adders? Because they're not even like transferred, so why would we need to? Yeah, I think what I meant to put was transferred. We'll go through each files transferred adders minus GamePy transferred adders, because we know the other client doesn't need the game ones. Like, we already verified that. And then minus progression pi, because that's server side only. I don't actually think this will even, I don't think we need to do this. Just like thinking about this after all the reviews I've done, because I've messed around like in this area, like this big circle, and this task kind of falls like a Venn diagram to where the other circle kind of overlaps it almost completely, to where like I'm fairly certain we won't even need to, like, I don't think we actually need to transfer any data to the other client. Not to mention, I've never seen any bugs associated with this, and you would think that if, you know, if there was data that was missing, it would be apparent, you know, like the other client would not show it. But like all the card data gets transferred, and that's mostly everything, you know, other than like the name. And obviously you don't want to transfer the progression text and the display text for one player to the other, because that's for that other player. So like, yeah, other than the cards, which are already taken care of, because we're talking about things that are changed client side and that are transferred to the server side, but that the other client on the client side doesn't know about. And it's just a question of like, does it need to know that? And the answer is most likely no. Like, almost certainly. Actually, I can just, from a general perspective, using just an overall view of how the game works, I don't really think we'll need that, but we'll check it more thoroughly when we come back. I'm gonna go to the gym. I actually feel more awake now. I took some more caffeine, that coffee, like, and I took some more vitamins, so I'm feeling more awake now. So I should hopefully be able to make it through the day, because I was feeling really dragged down, sleepy, like that head, you know, that feeling behind your eyeballs where it's just like fuck, and you kind of have trouble focusing. Anywho, so we'll minimize this. We got 1 2 3 4 5 6 7 8 9 10 11 12 more tasks, and then non-pressing issues we got a shit ton, but most of those are garbage anyway. I've said all this a bunch. We're gonna move this to the forefront, to the current issue tab, and get rid of that. And there we go. And I'll be back in just a little bit. Well, actually, we know we're going to come back, so we're going to just put and XX to XX, and we'll go ahead and copy this. Oh, see, that was clever. I never did that before. I always usually have to write that out again. Yeah, so I'll see you guys in a little bit, and we'll come back, and I'll probably do at least another hour. I'm trying to get back. I want to do like 5 hours a day like I was, but if I do